Okay, today I will talk about the overview of calculus. Keep in mind this is not a comprehensive overview of calculus. It's just my humble opinion of the calculus that you will actually need. Or for me, basically the calculus that's still in my brain after 7 years learning it. Those are the most valuable part that you will use for your future career as an engineer or other math related career. If you're a math major or hard science major, for instance physics, those are definitely not sufficient. So let's get started. First limit, I put a star on it because it's you barely need to use it. It's a foundation of all the outcome out of that. An example is basically when a of x approaching a, the x minus a is 0, but 0 over 0, but the same numbers, and then become 2a. I will not talk the example in details, but I will talk into each topic in relatively details in the future videos. And derivative, of course, we will use derivative because derivative essentially is a slope. So this is x squared, and the derivative is 2x. So basically showing you how steep at each point is. And 1D integral is basically to the reverse. As you can see, it's basically reverse of integral. So reverse of derivative. So 2x is the derivative of x squared. So the integral of that is x squared, and then since it's definite integral, then they go from 1 to 0. 1 minus 0 and equals to 1. And the integral is the same idea to 1D integral. You just forget about this part, consider x as a constant, and do the integral, and then do that next part. So what I mean is, you can think x is a constant, and don't worry about the first integral. Then it become 2x. Don't worry about that, and then become y squared, which you learn from the Funny integral. This is 1, as you know it. Then we get back to those things that you already know. And then it becomes 1, because you already know the answer of that from the number 3. And the fifth thing that is always a joke about physicists and engineers always use Taylor series, because we just take the first order or second order to go about our day. Which is pretty true. Which is true because most of our functions are smooth and infinitely derivatable, because we're dealing with real life. However, there's some cutting frontier of physics that won't work. So Taylor series is basically expanding a function into infinite series, but for a small x, it's considered to be a good approximation to truncate it. By truncating, I mean you just take the first few terms and see that is a really good approximation. And the exclamation mark means factorial. N factorial is like 1 multiplied by 2 by 3, 4 until n. And Stokes theorems and Gauss's theorem is very important and conceptually hard to understood concept. You won't use it most of the time, but for the people who want to learn more about physics, you will use that over and over. And if you are interested, and if you want, you have to learn the electromagnetism. This will be happening on the Gauss's law, and this is what will be happening on Ampere's law. So for this, you can think of if a function, it's a vector A is like this. If you draw a surface, any type of surface, any things goes through the that much goes through the loop, goes through the surface, the flux, the integrated flux, going through the loop, or equals to your integrated A around the boundary of the surface. That's like a Stokes theorem. And Gauss's law basically is with the enclosed surface. You can think this either as a source or a sink. And the A is, for instance, this is positive. You can think then it's like a spring, like a fountain. The water gushing out of it, and however much water going out is the flux, and this is the source. How much source it has is a volume integral, and this is the total flux, out or in, depends on the sign of this. So this in electromagnetism, you will see this. And this you will see something like that for your future electromagnetism class. Let me double check it in case I made some stupid mistake. And unfortunately I did. And this is like a really simple scenario of that, but you don't worry about it. This is the scenario for this. Yes.